So we are going to make now that case of the frame supported at the 3 supports and with a 1500 newtons force in a 1 point. We are going to make that model in a MKS, meter kilogram seconds, on the top front plane or top plane, doesn't matter. Going to make a line which will be 4 meters long. Then I'm going from that line to pull the line from the midpoint horizontal. Going to say that these two lines are equal in size. Then I'm going to drop vertical line, pardon, not from here, from the midpoint again. So I will drop the vertical line from the midpoint again. And this and this one will be equal in size. And I'm going to make another horizontal line from the midpoint. And we'll say that this one and this one are equal in size. And we see our graphic card how bad it is, that it does not really provide us the same resolution in X and Y. Okay, so now we have this structure. We are now going just to make it, we need to make it as a physical model. So what I'm going to do, I'm going to say that they are thick, no, that they are thick for a 0.1 meters. So if I just do the offset entities, and I can get it as a bidirectional for 0.1 meter. Actually, no, let me think, because we need to have the right dimension. We will not go bidirectional. We will just go in the same direction. Okay, 0.1 meter. And now we need to close the tabs. We need to close the ends, and we are ready to extrude this. All what we have to do is to close the ends. It's all closed. And now we can extrude this frame. Not in. I do not want it as a thin section. Although the thin feature may work, then we don't need actually at all to do any extrusions. Okay, so what I can do here, let's see. Extruded boss base. If I take this out, just need to choose all of the areas. And this will give me a little bit better control. And I will extrude it also for 0.1 meters. And here is my structure. Now, I'm going to place the position of that force, which is at 1500 newtons, and that position is going to be here at the point, and we need to create that point. And that point will be located at the extended of this edge and here, and it will be a vertical with this edge. So we are going to place a sketch on a top. And I'm just going to place a 1 point here, somewhere on the edge. Going to choose that point and this edge to be a coincident. And I'm going to choose this edge and my point to be aligned. Actually, this point and this point I'm going to choose to be, let's see, vertical. And that will bring my point in a proper alignment. And this is all what I need to solve this problem. Now, I'm going to make a new assembly, cross frame, and I'm going to bring that frame into my new assembly. And I'm going to make it to float. I'm going now to define my supports. I'm going to make, and let's see, point, we can call these points like this is the point E, the left is the point E, this is the point H, this is the point B, point A, point C, and point D. So we are now going to support it at the point E, point H, and point D with a top table, and we are going to run, and we are going to put the force acting at this point and run the simulation. So I'm going first to make the E vertical, so I will choose this edge, and I will make it coincident with global top plane. Click OK, and I'm going to call this one E. I'm going to rename it to call it the E vertical. E vertical. Okay. Now I'm going to support this edge here. And that will be my H. So I'm going to support this, not edge, the vertex, pardon, and the top plane. That will be my next mate. Oops, no, I did not want that. Edit feature, that will be actually this vertex at top plane. New mate. This vertex and top plane. And that will be the H. Let's rename it to H. H vertical. And now we are going to also make the last one the D vertical. This vertex and the top plane. That will be the D vertical. Now I will move to a motion study. I'm going to change the motion study type to a motion analysis. I'm going to set up a vertical force acting onto this point. And the force alignment will be along the vertical edge downwards. And the force intensity will be 1,500 newtons. And I'm going to put this into MKS system. Okay, we are ready to run the simulation. Yes, we are running the simulation now. And now we are ready to inquire the results. So to inquire results, we go to the XY, so the graph. We choose force, we choose reaction force, magnitude, and the component that we want, we will choose our mate. And let's see first what will be in a point E. And we know that it should be about 900. And it is a pretty much 900 for the numerical accuracy of the model, so 897. So that's my E. Now I'm going to inquire in my point H. That will be the H, and it will be a force, and it will be again the reaction force, and it will be a magnitude. And if I click OK, and as you can see, it is a 294 with analytical solution of a 300 newtons. So that's actually pretty close to the analytical solution to a point H. And finally, in a point D, we are going to find point. So point H is this one here. Point D is here. And we will do the same things. We are going to choose the results. And I'm going to choose the forces. And I'm going to choose the reaction force and the magnitude as a component. And I will choose this mate of the D and top plane. And I'm going to click OK. And this, it should be about 300, so 309. If we add together 309 and 897 and 294, what is the sum of it? It is 1500, so the total reaction is equal the action, and the Newton law is not broken, and we've got the solution. So this was an example of how easy we can actually set up the free body diagram of something that will be quite an involved to do by the vector analysis and to do the calculation by hand. Okay, and this completes this demonstration. Now you do it.